Welcome back, friends. Let's look at one of the videos created using this amazing tool. This is StableAnimator, the first end-to-end video diffusion framework that preserves identity. It creates stunning, high-quality videos directly, no post-processing needed. By using a reference image and a sequence of poses, StableAnimator synthesizes realistic, seamless animations effortlessly. Ready to revolutionize your creative process? Dive into StableAnimator today.
So let's start with the installation. So navigate to the path where you want to install and open the command prompt. Now let's first check the Python version. So this will work with this specific Python version 3.10. And second, check the CUDA home path. It should be 12.4. So if both of these match, the Python version and the CUDA, then you should proceed with the installation. Otherwise, you need to install these versions. Now copy this URL. Let's start by cloning the repository. The command for which is git clone and then paste the URL. Then navigate inside the clone repository and we will use Python to create the virtual environment. For that, you can use this command python-m venv venv. Virtual environment is created. Activate the same using venv /scripts/activate. Now we will start by installing the wheel package. The wheel package is installed, use pip install -r requirements.txt. This will install all the dependencies. Now, while the installation is in progress, you can download all the weights using these commands. So you can navigate inside the clone folder, launch a new command prompt. First, use git lfs install, and then use the second command to clone all these models. Now, once the installation is complete, just have a look if there were any errors or anything. There shouldn't be any errors because I have included the Triton wheel, which should work on this specific Python version. So now let's understand how this tool functions. So just look at the checkpoints directory. It should match this tree structure and all the files should be present in this. So this is the inference folder where I have created this animation 1 and we need a target video. And using that target video, we are going to generate the target images. And then based on that, we will generate the poses. So I have downloaded one video from Pexels. Let's use this for this demo. So I'm going to paste this in the inference animation 1 folder. Now we will also need one reference image, which we will be using to animate. So I have prepared this reference image. Now let's understand this tool supports two resolutions. One is 512 by 512 and second is 576 by 1024. So 576 by 1024 requires huge amount of VRAM. However, 512 by 512 works perfectly fine. So I have aligned the video and image to both 512 by 512 resolution. Now the first step is to extract the frames from this target video. For that, we can use this command. So just copy this command. Make sure to execute it from within this folder. You don't need virtual environment to be activated for this. And then press enter. You will see all the extracted frames here. Now the next command is to align the reference image with these images. So for that, go inside the StableAnimator folder, open a command prompt and activate virtual environment. Now we will be using this command. So the syntax is Python dwpos/skeleton_extraction.py. Now this is the target image folder path where we have extracted the images. This is the reference image path, and this is where the pose will be created. So we have inference animation. So this is where all the poses will be created, and press enter. Now once all the poses are extracted, you can just navigate inside the folder and see all the poses are extracted. Now the next step is to do inference. So first we have to update this particular batch file. So this is command underscore basic underscore infer. So open it in any text editor, and this is where you can update what is the output directory. Then you can leave all the checkpoints path as it is. Then this is the poses folder. So all you need to do is, if you are creating in a new folder, you just need to change these two names. Instead of animation one, you can use some other. And then I'm using width and height as 512 by 512. You can specify the FPS here. Rest everything you can leave it as it is. Once you have made all the changes, just close it. Now what we need to do is we just need to run this batch file. So make sure the full name appears here and then press enter. Now you may ask, in the original repository there is a Gradio based web UI. Why are we not using that? So basically I have wasted almost 24 hours using that, and I did not get any good results out of that. And finally, when I started using this, the results were much better. So that's why for now, we can use this command line inference. So this requires only 6.3 GB of VRAM for inference. Let's wait for the processing to finish. So processing is now complete. So if we look at the target video, it was around 4-second video with 25 FPS. That means 100, around 100, little less than 100 frames. And inference took 9 minutes, and the total video generation took 21 minutes. So thank you.